Assalamualaikum warahmatullahi wabarakatuh. Today we're going to present to you the title Diabetes Prediction using Supervised Learning. And my group consists of me, myself, NADHIRA, SHERIL DAMIA, AFIQAH NATASYA and SYAZA. We are from 2D. For the introduction, we all know diabetes is a chronic disease that can cause by high blood sugar level and can lead to the serious health issue if it's not detected earlier. So, machine learning, especially supervised learning, is increasingly used in healthcare for only diagnosis and prediction. So, in this project, we use PIMA, Indian Diabetes Dataset from KAHAH, and apply the random forest algorithm to predict diabetes based on health indication like glucose level, BMI, age, and insulin level. So, the dataset is labeled, making it ideal for supervised learning. Our goal is to build a reliable classification model to assist in early diabetes detection. So, we move on to the next part.
Assalamualaikum warahmatullahi wabarakatuh. I am SHARIFAH DAMIA BINTI IZZUDDIN, and I'll be explaining our Python code implementation. We use Google Colab because it allows us to run and test code directly in the cloud without needing anything. We use common machine learning libraries such as Pandas and NumPy for data manipulation, Matplotlib and Seaborn for visualization, and scikit-learn for machine learning operations. We load our dataset, which is the PIMA Indian Diabetes Dataset, from an online source in CSV format. Next, the dataset was split into input features X and target labels Y, followed by an 80/20 train test split to evaluate model generalization. To train the model, a random forest classifier was selected as the classification algorithm, configured with 100 decision trees and a fixed random state to ensure reproducibility. The model was trained using the training subset. Assalamualaikum warahmatullahi wabarakatuh.
Hi, my name is AFIQAH Natasha, and now I will explain the final part of the code, starting from step 5, evaluate the model. In this step, we evaluate how well our trained random forest classifier performs on the test data. First, we print the accuracy, which tells us the percentage of correct predictions. Then, we show the confusion matrix, a table that shows how many times the model predicted each class correctly or incorrectly. This helps us see if the model is confusing one class with another. And finally, we print the classification report, which includes precisions, recall, F1 score, and support. These metrics give a deeper understanding of how the model performs, especially when dealing with imbalanced data. Next, to make sure our model is not just working well on one specific test set, we perform 5-fold cross-validation. This process splits the data into 5 parts, trains on 4 parts, and tests on the remaining one, repeating this 5 times. We print the accuracy for each fold and then calculate the mean accuracy, which gives a more reliable estimate of how the model will perform in real-world scenarios. Lastly, we check the future importance. This tells us which features contributed the most to the model's decisions. The model gives each feature a score based on how useful it was in building the decision trees. We sort these scores to identify the most and least important features.
So as a conclusion, a diabetes prediction model has been built, tested, and also proven as reliable and fairly accurate. For the key takeaways in this project, first of all, the importance of understanding each features. For example, glucose level, BMI, and age are the most significant indicators of diabetes. So that's why it need to be included in the input to predict if the user have diabetes or not. So next is for this model can be improved with hyperparameter tuning, neural networks, or larger data sets. Last but not least, we have the experience to work with real world data, which is PIMA India diabetes data set, supervised learning, use supervised learning, and also evaluate model performance. So that is all from us. Thank you.